Well, g'day, Max here again. Welcome back to the shop. Well, I thought to myself, because I put some of you guys through such a traumatic experience of a review video, last video, that's if any of you's bothered to watch it. I know a few did. I thought we better get back to some serious machining. Now, just regarding those reviews, it's not something I do a lot of, and it's something I keep to a bare minimum. But what do? I mean, sometimes a product comes along and, well, this could be useful to me in the shop. So time to time, you're silly not to do them, you know. So they are time consuming for me, but it's just the way it is. So we've got a few machining jobs. Now we've got some little jobs to catch up on for the machining that we're doing on the apron of the JFMT lathe. So we'll get those out first, and then we've got a couple of lathe spiders to make, which will possibly be, I think, yeah, they'll be in the next video or the future video. So we'll swing it out and we'll show you what we've got to do. So if you remember a couple of weeks back, we turned up our new bearing. This was the old one, and we pressed it in. So we've got to machine out the scallop, which is this scallop here. I think it's really just a bit of clearance. This end cap goes in there, so there's nothing too high tech about it. So we'll just nibble some of that away, and we'll probably just finish it off with a die grinder, blend it in. There's nothing too high tech about it. It's just clearance. So we've got that to do first. So our next piece here is this little quadrant piece. So what this is, these are the detents for the lever, as this moves with the lever and locks the lever in place. And part of the reason why I wanted to strip this box down was it felt really wishy-washy in either direction when you lock the lever in, and that's because it's completely worn away. As far as I assume, there should just be four little detent holes in here, and this smooth, I think. Never seen a new one, so that's how we're going to rectify the issue. We're just going to have four detents put in, probably with a ball nose end mill. Now, I'm still deliberating on how I'm going to do this one. I could just machine up a complete new one, or I could do a weld build up on here. The tricky part is, either way, this has got to come in and out of the indexing head a few times to pick up the hole locations here, because they are very critical in relation to the mounting screws and this dowel pin here. Luckily enough, at the bottom, there's still location markers in here, so that's something I can pick up on. So whether I go to a weld build up or machine a new one, I haven't quite decided yet. So in the interim, let's get this bush done, and that's at least one part out of my hair. Of course, then it's just pop these in the lathe with these two parts from the other week, and we were just going to machine the shoulder back a little bit, so those lip seals that go on this shaft can sit in a little bit further and miss the grooves that were worn in the shaft. Now, I was asked a few questions a while back, you know, had I considered speedy sleeves for this option, and as soon as I seen the grooves and the way this was close to shoulders, speedy sleeves would have been, no, not really an option for this. One thing with a speedy sleeve, when you have a groove in the shaft like this, what I have found through past experience, if you put the speedy sleeve on, sometimes, not all the time, you'll still end up with a ring where this groove is, as the speedy sleeve will deform into this groove. I have had that happen before, and to get around that sometimes I have epoxied up the groove and then push the speedy sleeve on. In this case, the main reason for not using a speedy sleeve is because the length, that means we'd have to machine the speedy sleeve once fitted to length, and on either side we have the shoulder. So if you've fitted speedy sleeves before, you're aware of the lip that's on the end of them, and then that lip has to be removed. Now sometimes on a thin speedy sleeve, if you're not really careful, when you remove that lip, you'll damage the speedy sleeve, and as we're up against the shoulder, it would make it very difficult to remove that lip. You'd probably have to come in with a tool and machine it off possibly. So yeah, it's not really a viable option, I thought. So that's why we are shifting the location where the seals sit, as you'll see when we do the assembly. Okay, enough babbling. Let's just chomp this out. I'm just going to put a piece of cardboard here because that means there's less brass chips or bronze chips. I've got to clean out the casting when we do the cleanup. Right, that should make the cleanup easier. And just coming down slowly on the power feed. That's about as far as we're going to be able to get that, so we're just touching the casting up here. This will be a bit of a taper in the casting down here or whatever. Anyway, we'll just deburr that, probably just with a Dremel, and that's this part done. Policing my brass. You'll be amazed, but even little jobs like this, you keep the brass or the bronze. It does build up over a couple of years, and you have a big bucket, you take down the scrap yard and you get good money for it. Okay, so off camera I'll do the dimple for the locking set screw, and that's that part done. Right, that'll let our lip seals sit in a bit further to help miss that groove. Another part done. Definitely steel by the colour of the sparks that came off then, not some sort of cast iron. So now we know this is steel, so it's weldable with the MIG welder. What I'm thinking of doing, I'll set this up in the rotary table and we can index these 5 positions here in the rotary table, and we can take this out. Of course, we record our index positions. We take this out, we do a weld build up on here and then smooth it back down, and then we can set it back up in the rotary table and come in with a round nose end mill and spot our 4 main locations here. I'll spot one in the center for the neutral position, and I think we'll just cut a very shallow cross groove in it, just to take any wishy-washiness out of the lever, to keep the lever on a positive track when it's shifting. So I think that's our plan. Zero the dial on our saddle. So if I come across 16.54 millimeters, that'll put our spindle of the machine on center on our shaft, and then that puts us in a position where we can start mapping out the locations of these holes. So we're on center now, and I'll just come back and I'll just re-zero my dial, just in case, you never know. So we'll just use the other end of our edge finder. We can come down, and that way we can locate the center of these little dimples that are left. Okay, I'll set our table now on a 0 there. So now we're located around center here. I was moving this just with it only very lightly gripped in the chuck. So now I can tighten the chuck up. So now we've zeroed our table in the center position. So we'll come up, we'll go past our location, and then turning the handle in a clockwise rotation, we'll pick up a number for our end position. So that's interesting. So we're spot on in the centre of that one. When we come up to this one, the position of this one is slightly to this side, and the position of this one is slightly to this side. So I don't really know what's going on there. There is a little bit of slop in the keyway. So what we're going to have to do is set up another block and put a toolmaker's clamp here to clamp it. So I don't know why there's that little bit of offset here. Let me have a think about it, because we might, well, I'm hoping I don't have to do a sideways offset, but it's looking like it's going to be our only option to keep with the original locations, assuming the original locations are drilled in the correct spot. Okay, so I've decided that that little difference, this one dimpled slightly to this side and this one slightly to the other, is negligible. It's not going to have any effect, as the motions that this part goes through are purely a rotational movement that way, perpendicular to the axis, and a straight longitudinal movement parallel to the axis. It's just a ball bearing detent that goes in there. So we're going to stick with and keep everything on centre to line up with our centre position. So what that means is we've got our table on 0 there. So our starting position will be this hole up here, which we start on number 1 on our dial. We move down 14 millimeters, brings our table dial to 0. Move down another 14 millimeters, brings our table dial to number 4. So we'll come back and re-zero our table. Okay, we can now lock the table and use our rotary table function to pick up on these 2 holes here. Whoops. So I'll start with this. Oh, for fuck's sake, I just fucked my last edge finder. Wouldn't that rip your undies? Fucking goddamn horse shit. Let me go to plan B. Well, I suppose my only saving grace here is Toyo in their wisdom. The springs screw over the thread on the ends of the ends. Unfortunately, it snapped the one off on that one. The spring, the end is still snapped inside. So in a pinch, I could salvage this one by screwing a screw inside there, if I can get that broken piece out. Okay, so plan B. My Starrett one that had the overspeed adventure, I managed to hook a bit of MIG wire down there and rehook the springs back on. So she lives to fight another day. Okay, that seems pretty central there. So I'll mark the hole we're indexing from. Okay, so on this top row of holes here at 12 o'clock, on this index plate, this is your generic starting position. This is where all the holes are numbered from. It's where all the holes are in a straight line. So when we set up and we did where we picked up the middle dimple, this is where we started from. So then we've wound back, so let me reset the clock. So up here, that's where we picked up our centre from, and now we've got to wind it anti-clockwise past where our new spot is, and we'll come back round clockwise to take up the backlash. This marked point right here is where we just picked up the centre of our new location. So this then becomes our starting position. So then we have to crank around 1, to 2 2/3 of a turn till we pick up our 0 spot. So I'll just write that down, and then we can continue cranking past our centre position until we come around to, we don't need the sector arms, we're ignoring them. Okay, let's pick up our new spot, but it's going to be in this position somewhere around here. Okay, that's it there. So then that becomes our other location. So our last hole location, past our 0 on the plate, is another 2 2/3 of a turn. The 2/3 is only an approximate number just to get us in the approximate correct area of the plate where we've marked it. So that one there, oops, is this one here, this one here, is this one here, and this one here is this one here. And then back from centre, it's just a 14mm shift to our 1mm position on the dial for this one here, and likewise for this one here. So we actually start at this one to keep all our backlash off. We start at the 1mm, we wind the handle clockwise till we hit our 0 position, puts us in the middle there for our middle hole. We keep winding another 14mm till our dial reads 4, which means 14mm past our centre. So we'll get it set back up in its 0 position. Centre position there. And what we need to do now is set up a block here, something we can put a toolmaker's clamp to, just to eliminate this little bit of play that's in the keyway or locating pin, whatever locates this onto the shaft. Once that's set, we can take it out, and then we can, well, I can take it out of welder. I could actually weld this in situ. That would have saved me having to, I think I'll do that. I think I'll weld this in situ in the machine. We'll put down some protective covering, and that saves me having to try and reset this up again. And I'd have to reset up possibly off an edge like that or something. Now let's just check this with a square anyway, because it would be interesting to see how this lies in relation to these holes here. And it does, that's dead square. So in actual fact, we could, that's spot on dead square. We could actually take this out the machine and weld it, knowing we can pick up on here. So yeah, we can re-reference our shaft here because this is dead square. Okay, we can take this out and then we'll be at the point of no return. At least we have this edge here to reference from, and we must have got this right, I'm guessing, for that to come up dead square. So out she comes, and we'll head over to the welding bench and get this all filled in and smoothed back off. So we'll do the build up here now. We're going to be using ER70-6 filler wire, and we'll put that in with a TIG torch. Okay, that should be enough for there. We'll go crossways now. Okay, we'll head over to the lathe and we'll get this smoothed off. I don't know what's going on here, why this has been ground away, and that's something we won't know till we go to reassemble. And likewise, just here and just here, you can see grind. I've had a grinder in there for some reason, so something's gone on. So we'll have to investigate, and like I say, we won't know until we go to assemble the part up. Then we can see why this has been done. Okay, so we'll head over to the lathe and we'll get all this smoothed off. I don't know how it'll go with this little bit of play here, so it might give us a few chattery marks, but we'll see what happens. That's as far as what I dare go with that. So we're sort of touching right up the end, missing the middle, and we're picking up the end on it here as well. I'll just let that be, I think. So while we've got it held firmly in the lathe, let's just make sure these screws are nice and tight, in case I've slackened off with the heat. Yeah, no, that one was good. That one there came up a little bit. So I think I'll take this over to the belt sander and just give it a slight tickle up and see if we can get this weld to blend in a bit better. We can't machine it anymore because we're already contacting the edges back here and it's missing the middle. So belt sander it is. Okay, quick go on the belt sander. Soon flick the wrinkles out of that one. So we'll get a reset back up. Feels good there. Okay, so we're all clamped up here now, and that takes out that little bit of slop where this mounts on. So what I want to do, we're going to use a center drill. We're just going to spot them first. We should be right, but we need to make sure we're right. You've got to be right to be right. We don't want to make a pig's ass of it. I think if I'm going to make a mistake here, it's going to be 5 millimeters out longitudinal. and well, going the other way, the indexing will be right. This, I think we're looking so our holes are 28 centres, so we're looking in the ballpark. So let's go for it. Actually, we fucked that up. We're supposed to be there on the 1 mark. Okay, let's go again. Okay, we'll take our clamp off and we'll do our rotational checks. We need to come to our starting point. Which is there. And reclamp. Okay, we'll come round to our other one. Which is there. Reclamp. we're in a good place. Let's change our cutter out and we'll put our ball nose end mill in. Okay, so our ball that sits in, I mean this is the old one, and it's pretty corroded and it's knackered. So it's about 9.5 millimeters. So it could have even, I don't know how it started life, as 9.5 or 3.8. So I do not have a ball nose end mill. I've got 8 millimeters and I've got 10 millimeters. So what I'm going to do is go down to predetermined depth here with a center drill, and then I'll go on with a 90-degree countersink and just open the hole up. We'll just slip our clamp off. And then index without bumping the camera stand. We'll come back to our start position, which is there. Put our clamp on. So we'll swap out our center drill and go on with this countersink, see how we're looking. I'm tempted to roll with that. Yes, it feels pretty positive, so I think rather than overcut it, we'll roll with that and we'll revisit this on assembly and we'll just check the feel of it. Well, I think I'm just going to leave that be, and once we assemble this back up in the gearbox, if we need to modify it, we can do so then. If we overcut anything now, it means we've got to fill back in, you know, so I think it's better we'll let it go at that, and we'll have a test fit or on assembly. Right, well that's just one of those jobs where there's a lot of guesstimation involved. So you don't have anything concrete and specific to work to. So, as we said, on assembly, it'll either be right or it'll be coming back in the machine. So this gives us a really good starting point to work with. We'll see how, well, all we can do is see what happens. Well, I set the lever in the housing and it does, I think we've had a win. It does appear to be doing what it's supposed to do, so clicks into there, perfect, back to neutral. This is your cross feed, so we'd be feeding in, neutral, feeding out, feeding towards the chuck. It's clicked in perfect. Neutral, feeding towards the tailstock. So our ball bearing and spring are inside this little tube there. I mean, it has to be all right because everything is lining up on this end of it. It goes to maximum travel, but it's not jammed up on maximum travel. So I think we're on a winner. So I might do a little modification here. So what actually happens, and I think what's caused all this wear, in this tube you've got the spring going directly onto the ball bearing. Now that spring's putting a lot of friction. It's not letting the ball bearing roll, as the bearing should roll on this, not skid across it. So I think we've got to modify this assembly here. Well, that Allen key is the adjuster for the preload. And this whole lot can come out. So we could possibly do something with this. We'll make up a new spring and possibly something maybe along the lines of a bronze or a Teflon spacer that cups the spring, part of the spring, and pushes on the ball bearing. So whatever pushes the ball bearing has got to have less friction than the rolling friction of it on here. Otherwise the ball bearing is just going to skid, and that appears to have been what's caused all the excessive wear, I think. Oh, well, our next job is eagerly waiting in the saw there. So we've got a couple of these bushes to make. So these will be spiders for the JFMT lathe and for the Heron lathe. You'll see how they're used after they're made, as we have a job I want to do which requires the use of one of these. Yeah, well that wasn't half fiddly, but I think we will call that one a win. And well, that's another couple of little jobs knocked off. So now I can go ahead with the assembly of the apron, and we need to really crack back on into the JFMT lathe. But there's going to be a slight distraction, as there always is. Those little sketch I just showed you. We've got a bit of turning to do in the big heron lathe, and I need one of those to be able to do it. So we'll get more involved with that on the next video. So anyway, cheers, thanks for watching, and hopefully see you next time, or you'll see me.